Hello, Year 13. We are going to use our normal distribution today to, or we're going to use it in reverse. So what we were looking at yesterday, these kind of problems here. So using the normal distribution to work out probabilities. And here, I know that this particular plant crop has a normal distribution. So please do use the notation. It will be really helpful when we come to do different things with the normal distribution in a couple of weeks' time. Mean 65 and the variance is 36, so I could write 36 there, but you've seen many questions have it written as 6 squared just because it means that we can easily see what the standard deviation is. You can, if you want, write by the side the mean and standard deviation are, but by writing it in that bracket, we just know it's always that way around. Find the proportion of plants that are taller than 70. So I need to work out the probability that X is greater than 70. So taller than 70, so I can put greater than or equal to, but because it's a continuous probability distribution, it doesn't actually matter. So on our calculators, we go to distribution. So this, of course, is in stats mode, normal, NCD. I have already typed in, I want the lower to be 70 and I want the upper. We generally just typed in a really, really big number. And of course, what we often did, well, what I encouraged you to do, and we're going to be doing the same again today, sketch the curve. Okay, think, right, because I have got 65 there, I need to look at an area of 70 and above. And it gives you an idea of what's going on. It gives you a feeling as well as to how big it is. All right, so I know I'm looking at an answer less than a half. I don't know, 0.3 maybe, but it means that we can have a quick check if we get an answer of bigger than a half, we know we're wrong. So I've already got in, oh no, I haven't got in, have I? I want 6 there for my standard deviation, and then I want 65 in there. So my lower is 70, my upper bound, I just type in a really big number. So we could just press go now, but I actually want it to draw the graph because it's always nice to see what's going on. Okay, remember this has been transformed, so it's got a mean of 0, so it always transforms something like that, but we can see that the picture there is very, very similar to the picture there, and crucial thing is telling me that the probability there is 0.202. Okay, so there we go, there's our answer. So that we did yesterday. What's going to happen today, however, we are going to ask our question the other way around. So we are told what the probability is. So if we were told, okay, what height would the crops be for the top 20%? So this is effectively 20%, isn't it? A probability of 0.202. So if we're given that answer, but then we had to figure out what that number is. In other words, we had to figure out what this value was here on the axis. Okay, and the same situation I've got here. But what we need to work out is what these bottom 10% of the crops are. So sketching the curve when you're doing the inverse problems is even more important. So I was encouraging you to do it yesterday. However, every time, draw it, please. Here is my mean, sorry, it should be straight line, 65. The bottom 10% of the crops are destroyed, so that's going to be quite a small area. So I'm going to call that value A there, and I am going to have on a shaded bit there. So I know that that area is equal to 10%. So you'll see that when we go onto the inverse menu, it actually gives us the area. It doesn't talk about the probability, but we know that this is effectively a histogram. Area represents frequency for a histogram, area represents probability here. So we need to find A such that the probability that X is less than A is equal to 0.1. So we go to the calculator, and you'll probably remember this from previous questions that we've done. If we go to, so I need to exit, go into distribution and go into normal, there are three options. The NCD, the one in the middle, is the one we've been using. The one on the left, don't think you're ever going to need that. Inverse N, inverse normal, of course. So what value gives us that particular area? So you can see if I go down under the tail option, I've got three. I've got a left tail, a right tail, and then a central tail. Obviously what I've shaded in there, which is why the diagram is important, it's looking like the left tail. So I've got the left tail already there. I want the area to be 0.1. I've still got the same standard deviation of 6 and mean of 65. Okay, and if you go down here, there are no options to draw the graph, I'm afraid. It's just all about the calculation. And it just gives us the answer. So 57.3, A equals 57.3, and that is a height, so centimetres. And then having the diagram there can help. Okay, does 57.3 seem sensible there? Well, yes, it does, doesn't it? The mean is 65, and it's a decent way to the left. Yep, so I'm happy with that. That looks good. So what we're going to do today is just essentially practice using that function. The questions can get a little bit more tricky, especially when you've got combined regions, which you'll begin looking at shortly. Those of you who've got slightly older model calculators, we will be able to find ways of getting your calculator to work. When we have the left, right and central option, I think you may only have the left option, but I'll talk about that on the question B here and moving on. So I want to work out the value of A such that the area is equal to 75. Let's sketch it. Every single time, sketch it. My line down here, that is, I think, the best yet. 20, the mean is 20. Now this time we want the area to be 0.75. So to get an area of 0.75, I know that everything from here to the mean, that's all got an area of half, 0.5. So obviously if you get 0.75, I'm maybe going to be going to that point there. We're going to have all of that. So let's label our point A there. And for these questions, there's not really that much working that you can write, but we need an A such that I'm essentially just going to write out the question here, aren't I? The probability that X is less than A is 0.75. Let's write on here that I want the area equal to 0.75. And then we just look it up. So, calculator, go back, exit. So I'm already in inverse normal. I want the area to be 0.75 this time. I want the value of mu, sorry, sigma first, sigma is 3, and the mean mu is 20. I want the left tail, yep, that looks good. To 22.02. 22.02. And again, just check that looks right. We want somewhere above 20, 22.202 rather seems to fit the bill. Now, this next one, we want a value of A such the area above it is 0.4. So, oh, I'm drawing in that line first. That's always a little bit dangerous, isn't it? Can I get it symmetrical about? It's not far off. So that is my mean of 20. So I want a value of A so that the area above it is 0.4. And actually, it's not far off what we've just done, is it? 0.4. I've got a line coming down here. The area above it, so this area here, I want to be equal to 0.4. So what we can do is use the right tail with an area of 0.4. And again, there's nothing else I can really do working wise, and I need the probability that x greater than a is 0.4, but that is just really stating the question. We just go to the calculator, we type in the things, so it's the same distribution, but what I want to change now is change that tail to the right hand one, and my area is now going to be 0.4. Still same sigma, same mu. 20.7. So A is 20.7. So I get an answer that's closer to 20 than the previous one. So note that the previous one was 22.2, but of course our area before was 75, which meant that that remaining area, that blank area, so this area here, I'm just looking, I don't think you can see my mouse moving all the time. This area here, whoa, I think you can see it now. This area here is equal to 0.25. Now, if you don't have the option, I think the older models don't enable you to do the right tails. Of course, what you can do, if you know that the area of the right-hand side bit is equal to 0.4, the area always adds to 1. So I know that that area on the other side has got to be equal to 0.6. So if you don't have the newer calculator, we can just see that we can use an area of 0.6 with the left tail. So we know that the answer is 20.7. Let's just look and see that we agree with that same value. So change that to left and change this to 0.6. 20.76. 20.7 was the previous one, 20.76, and I just did some shocking rounding. A is 20.76. I'm going to have to go back and look. Area 0.4. Tail right. Yes, 20.76. I'm sure you all noticed. So 20.76. Let's just add 6 there. I apologise. Okay, so just a couple more regions, slightly more complicated. If you can look on this first one, it is just a simple, okay, I want to find the probability greater than, so we've done one similar to that. But look here, you've got an in-between probability, and then similar on the bottom one as well. So of course these ones a bit more complicated. How do we manage them? Well, first thing, every single time I'm going to draw the graph. There's an approximation of the curve, looks different every time, doesn't matter. This is just to illustrate and help me to figure out what is going on. So there is my mean of 80. Look at the probability that x is greater than my value. I want it to be 0.65. So it means that A's got to be the left-hand side of the mean, so that then when I'm finding my area, I can think about that area there as 0.65. So I'm just going to write here using the calculator. There's nothing else we need to say or do. I can maybe spell this out a little bit more. I'm going to be using mu as 80 sigma. The variance sigma squared is 49, so we square root and get 7. So that's what I'm typing in. I can see my diagram. I know that I'm using the right tail. So those of you who don't have the calculators, the latest models, you would use the left-hand area of 0.35. So right, no dear, didn't actually change anything. Right and 0.65. Is 7 and the mean is 80. Answer is 77.3. Okay, and that looks good. Yeah, to the left of the mean. Wonderful. Now, next one. So take a bit more time here, or I'm going to take a bit more time with my diagram. I'm not going to go down there though. Determine the value of B such that, okay, so there is my curve. There's my axis, and my mean is 80. Right, now one of the values I'm thinking about is 75. So 75 is the left-hand side of the mean. So let's draw. A line down there at 75. And then I'm needing a value of B so that the area between 75 and this value of B is equal to 0.4. So where could I put B? So B is most likely to be over here, isn't it? Because I know that halfway is a probability of 0.5. So I'm going to put my B on there, and then I want this red area here to equal 0.4. Now, if we look at our options on our calculator, sorry, let's just write first. I want that red area to be 0.4. Just that bit in there. Now, if we look at our calculator options, we had a left-hand option. We've got the right-hand option, and then we've got a central option. Now, annoyingly, central means exactly central, so it has to be symmetrical. So even though here you might think, okay, well, I've got the 75, which is on the left, and I've got the B, which is on the right, they're not centrally about the mean, so I can't use that option. So what we need to do instead is to use the fact that what we've got here are two areas. I know that the area all the way from B and below is written or can be thought of as the red shaded area plus the green shaded area. So the probability that we want between 75 and B, that is equal to the probability of everything less than B, which is red plus green, minus the probability of X is less than 75. So that is the red bit, and this here is the green bit. So before we can use inverse normal, what I need to do first is to work out the probability of that green bit. The probability of the green bit is just what we were doing yesterday. So that bit there, we can just get from our calculators. And of course, the answer to all of that is 0.4. So then we'll have two separate regions that we can add together. So first, again from the calculator. So this is all from the calculator. The probability that X is less than 75 is equal to. So now we are going into the normal distribution. Sorry, so I pressed the wrong thing. Exit distribution, normal NCD. I have got my lower, I want it to be all the way down there. So let's go with minus a really big number. I want the upper boundary to be 75. It is still 7 and 80, isn't it? So yes, my standard deviation is 7 and my mean is 80. Let's just get the picture there just for reassurance. So that is F6. Do I have to press the arrow button? No, F6 it needs to be actually on the screen. Yeah, it sketched it for me. That looks good. So look at the probability there, 0.2375. 2375. So what that means, this probability, the green bit is 0.2375. I want the red bit to be equal to 0.4. So that then means that we want B. So therefore the probability that X is less than B is equal to the 0.4, the red, plus the 0.2375. So I want an area that has got 0.6375. So I now use that in my inverse. So now use inverse normal with an area, a right tail area of 0.6375. And we get that B is, so go to the calculator, exit again, distribution, normal, inverse normal. So left-hand tail, because it's the green and the red section, I want the area to be equal to 0.6375. And there we have the answer, 82.46. 82.46. Okay, so we just got to find that extra little bit of area first. And a couple more, but hopefully that'll be a bit quicker now that we've got the idea. So determine the value of C such that the probability between C and 76 is equal to 0.2. So first, sketch. There is my AT. 76 is going to be to the left-hand side. Let's say there, let's just draw a vertical line. There is 76. C is going to be below that. Let's say put it there. I want that area there to equal to 0.2. So I look at my diagram. I can easily see that that shaded area would be the same as the complete area below 76 minus the area below C. Sorry, that should be X is less than C. Okay, so shall I mark that on? So that is that little orange bit. That's the bit that we don't want. So this I can find on the calculator, the probability here. So the probability that X is less than 76 from the calculator. So I'm on the same distribution, but I need to remember that I'm not in inverse normal. I need to go to the NCD. I want the probability of the left-hand tail, but this time I want to change that to 76. Everything else there is correct. That is 0.28385. So now we can either use this equation here and think, right, how do I rearrange that to get the probability X is less than C as the subject, or you can just look at those areas, can't you? Whoops. Why did it do that? We know that if we work out the whole area, well, which is what we have, so we know that the whole area is equal to 0.283. I know that the area of the shaded bit here is equal to 0.2, so I need to subtract them. So you can either look at the areas or rearrange that equation above. But either way, I will be getting 0.28385 minus 0.2. So that is the area that I need to use the inverse normal on. So use inverse normal with an area 0.08385. Go to my calculator. So I just need to change that 0.08385. We get an answer of 70.34. This is C, 70.34. Okay, look at your diagram. Is it sensible? Yep, less than 6, considerably less than 6. Yep, happy with that, looks good. Okay, now we do have one more. However, it isn't quite as scary as it maybe first looks. Because determine the interquartile range. Now, if you think about what interquartile range is, the interquartile range tells us the distribution of the middle 50% of the data. Okay, and of course, this isn't just the case for normal distribution, this is for any distribution. So the lower quartile, oh, no. Sorry, I did an automatic rub out before. I'm not really good at getting it. All right, let's just undo. So I'm trying to type in, right, lower quartile here. Oh, I've done it again. Sorry, everybody. L, Q, and up here, we have got upper quartile UQ. I know that that area in between has got to be equal to 50%. So that area is 50, and not only is that area 50, of course it's symmetrical. So I want that area, I keep saying 50% or 0.5. But we know that the lower quartile and the upper quartile are symmetrical about the mean. And technically, the lower quartile and the upper quartile are symmetrical about the median, but in a normal distribution, the mean, the median, and the mode are actually all the same for the normal distribution. So here we can actually use the central area, because we do have that symmetry. For those of you who don't have that central option, it's simply enough, you just need to do the bottom area below the lower quartile as being 0.25, and then to the left of the upper quartile just having an area of 0.75. So you would need two different values. If you've got the new calculators, it's just one thing that we need to do. So the area, I'm going to type as 0.5, and at the top, we're going to go excitedly for the central area. Two values, x1 and x2. So the lower quartile, I need to remember two numbers, didn't even remember the first. 75.23. The upper quartile, 84.72. So the interquartile range, I need to subtract those. 84.72 minus 75.23. 9.49. There we go. Okay, and of course you can just use this for interquartile range. You could use it for the middle 40% or the middle 70%, but it is a little bit rare, the situation where you'll be asked to work out the range of the middle without it being interquartile range. Okay, so for the rest of this session, and also to finish off the homework, inverse normal questions. So there are 12 questions there, but most of them are just like a single type in your calculator. However, there are some that have got those in between bits. So my answer, some have got the full calculator instructions, some have just got, well, I've got my scribblings and my diagrams there. Okay, but hopefully that is okay. Any problems, please get in touch. I won't set this as an official assignment, but of course we're going to be doing more complex things with normal distribution next week. So make sure you have completed all of yesterday's and today's questions, please.